Hi everyone, in this video I want to walk you through some of the basics of Visual Studio. Let's start with the first thing you see when you open Visual Studio up. I'm running Visual Studio 2019, so this interface may look slightly different from say that maybe you're using 2015 or 2017, which use more of like a full screen kind of a setup, but the layout is very similar. So on the left you have the Open Recent section, and so here's where your different projects will be split up through like today, this week, this month, last month, etc. If the project you want to open isn't in this Open Recent section, then you can move over to the Get Started section, which in the older versions is called the Open section. And here we have a few options. Here we have clone or checkout code, where you can basically run code off of GitHub and stuff. But we're not going to be working with that. We're keeping it to the basics right now. So we have these three options right here. We can either open a project, an existing project. We can open a folder, which is not the same as opening a project directly, and I'll explain that in a second. And we have the create an entirely new project option, which is self-explanatory. The difference between opening a folder and opening a project is, if you're sort of familiar with Visual Studio, you may know that when you create a project, you'll end up getting a folder with a bunch of subfolders, and you'll get like the project file. You get any of the source files that are in it and all that stuff. Basically, the open project or solution option would be letting you actually open this .sln format directly. But if you just do the open folder option, it's completely different. Let's open up test and see what happens. This is the exact same project. Let's see what happens when we open up the folder. So now it's like it's all blank here, and this setup right here is weird. It's like, what is all this stuff? This exe, we have all this debug stuff. Like, what do I even open? Well, what you'd probably want to do at this point is double click on test.sln and basically open up the project through that, and then move on to your code. And that would accomplish the exact same purpose as opening it directly. So like I said, I want to just keep this video simple. I'm not going to go into this code section with GitHub, and we'll be opening up some projects later on that I've already set up. But right now I want to guide you through the creating a new project option. Since I have C++ installed, these are all the different options that I have. So let's go and click on an empty project, and we'll click next. And we'll, I guess we'll just call this project 1 and create. If in your options you want to work, say, with Java and you accidentally installed C++, that's no problem. What we're going to end up doing is we're going to open the Visual Studio installer, where you can actually install any programming languages you want, and I'm going to show you that right now. Looking at the opening screen of the installer, you'll see a list of all the Visual Studio versions that you've installed, as well as another tab of the different versions of VS that you could install. To install any programming languages you want to work with, you want to click on Modify on the Visual Studio version that you want to work with. So let's do that. With this new screen, we have 4 tabs on top. We have Workloads, Individual Components, Language Packs, and Installation Locations. To keep things simple, you only really need to use the Workloads tab and maybe the Language Packs if you want to run Visual Studio using a language other than English. From here, you can select various supported languages to install, including Python as of early 2019. You can see here that I just have desktop development with C++. However, if I were to deselect this, the installer will actually automatically uninstall the whole package for me. As you can see, it says minus 4.03 gigabytes. If you're an advanced user, you can go into the individual installation package here at Installation Details and select what individual components you actually want to install. Say for some reason you want to install both Python 2 and 3 as 64-bit and 32-bit variants. So you can do that as simple as that, and then click Modify and it'll install everything for you. Let's go back to the regular Visual Studio program. So right now you should be greeted with just a blank interface with some extra windows around the screen. Maybe not in this exact layout like I have it, because this is a specific setup that I like to have. I want to give a quick tour of what I think are 3 of the most important windows to have open in Visual Studio at all times. So here we have the Solution Explorer, where you can keep track of all the different files, be it text, header, image, or source files, in your project within these folders. As an amateur programmer though, you'll likely just be working with the header and source file folders for most of what you do. Next is the errorless window, which is crucial for keeping track of not only what kind of errors are in your code, but exactly where they are. So let's create an error. Let's take off that quotation mark. We're definitely going to get an error now. Let's look here. Not only did it expect a semicolon, but it is missing a closing quotation mark. Let's look at exactly what line that is. Line 6. There we go. Line 6 missing a quotation mark. Oh wow, looks like I forgot. Let's throw it in there and we're done. It's all fixed. No more error codes. So obviously this is very, very useful to have. Last but not least, we have the output window, which tells us plenty of important information like what source files are running, if the project was built correctly, and depending on what version you're running, the code the project closed with, which could be very helpful for knowing what caused the program to close. If you don't have any of these windows already open, don't worry, you can go to View and select any window you want. I also want to do a demonstration of what shows up in the output window when we run it, so let's do it really quick. We see a few things popping up here and we have our output. So we have our hello, we have exactly what ran and what code it exited with. See, sometimes depending on what version that you have, either the exiting code will be on the actual console or it'll be down here in your output window. So I think it's in older versions where the exit code will be in the output window. So let's see, we have build started on exactly what project. So this is our test project. And we have our source.cpp being ran here. And, just important information, the build was succeeded and then it ran. There we go, and we're done. Right now, you may be wondering why my version of Visual Studio isn't blinding me. Well, I'll show you how you can turn on the program's built-in dark theme. Simply go to Tools, Options, click the drop down next to Color Theme, and select Dark. And now your eyes are saved. You're welcome. You may be wondering how to even start writing code. I mean, if it looks anything like this, like where do you start? You don't have a file to be working with here. It's just blank. Well, the first thing you want to do is right click on the source files folder, go to add, new item, and here's all your different options. So obviously since I only have C++ here, it's just showing me the C++ options. So you can create a new source file, which can be anything from a header file to a text file to a bitmap file. But right now we just want to do a normal C++ source file. So let's do that. I'm going to leave it named as source. Let's add it. And look at that. Now we have a file that we can work in and start writing code in. And look at that. Now we have the exact same code as we had on our test project. Now is as good a time as any to briefly discuss how virtual environments work in Visual Studio. Or rather, how they don't work. If you try running a project with multiple source files like I have here, all of them will be run at the same time and basically be treated as one big source file. Because of this, if you have a main function in both source files, you'll get an error saying something like main already defined in. So let me demonstrate that. I have a main here on num2 and I have this, I renamed it to uno since this is num1, but I'm going to make this a main. So let's try running this. We have an error, unsurprisingly. Let's look at our error list. So these are all warning errors, not really as important, but these are critical errors. Main already defined in num1.object. This file has a main, and this file has a main. So obviously we're getting an error here. If we run a file, it isn't just going to be isolated in that environment. We can't just run the file. We have to do this weird workaround because Visual Studio doesn't really deal with virtual environments. I also want to mention if you have multiple source files sharing the same variables or functions, you'll get a similar redefinition error. Like I said, to avoid this, make sure to rename the main functions of the files you don't want to run. So I'm going to rename this back to uno and save that. This principle may likely not even be consistent across all IDEs, especially those that utilize virtual environments like, for example, PyCharm. This is just a rule of thumb to keep in mind when using Visual Studio. Say that you want to write code for some text file I/O for a project you're working on. You're obviously going to need at least one file to do so. You have two options. Either you create one using the source file creation method, which is what I did here, add new item. I think I have text files under utility. Yep. So you can make a text file right here. And there you go. Simple as that. Or you can bring in an existing text file from outside your project. To do that, there are two methods as well. Either you right click on the source file folder, go to add an existing item, which would be the easier method. Or if you want to make things hard for yourself, you can go to the file you want to include in your project, copy it, go to your project folder and paste it there. So for example, if I want to get a random text file, Let's say I just want to copy pointer stack and I want to paste it right here. If it isn't obvious already, the text file isn't here right now. The reason for that is because the file isn't actually being included in your project. To include the file, click on the Show All Files button in Solution Explorer, and now you should see your file with a little warning sign on it. What you want to do is you want to right click on it, go to Include in Project, and there you go. So there's really no reason to do this whole workaround when you really just could have gone to add an existing item. Unless there's something I'm not aware of, that is the most streamlined approach and makes the most sense. This next section is very important, knowing when to run a project with or without a debugger. Say you've done some decent headway into writing up a program and you just want to see if it runs. To do that, go to Debug and start without debugging. This way, you're jumped into a console and you can see whatever output you've set up. As a side note, I know many people who have the tendency to manually build a project before running it by selecting the Build dropdown and selecting Build Solution. However, I say that it's a waste of time because Visual Studio automatically builds your project before running it anyway every single time, so I wouldn't really bother with that. Now, say you run a project that calculates some values and you notice the output is way off. Clearly something is wrong with your code and you want to find out what it is. Well, that's when the debugger is your friend. First, we should add at least one breakpoint somewhere in the code just before where you think the error could be happening. So I think the error might be happening in my calculation right here, so I'm going to add the breakpoint just above it. You'll see why I do that in a second. To run the debugger, go to Debug and click Start Debugging, or you can just press F5. Now you'll see a few different windows pop up, like the call stack, a list of your breakpoints, the compiler output, various exception settings, and what I think is the most important window, your local variables. Keeping an eye on your variables as the program runs is vital to understanding exactly where and how something went wrong. I also want you to notice that the program ran up until our breakpoint, which demonstrates just how valuable the breakpoint feature is. Imagine you have a giant, like 800 line program. If you have your breakpoint somewhere in the 650 line mark, then you don't want to be going all the way through that program just to get to that one point. No, you want to throw that breakpoint somewhere in the 650 line mark and have the program run all the way up until that point. This way you don't waste any time and you go right into the action. What you'll want to do from this point forward is use the step into function right here, which uses the shortcut F11. Every time you click it, the program continues running line by line. Doing this, you can easily keep track of your variables as well as what the compiler is doing with your program, like looping or jumping to functions or classes. So let's click on this and see what happens. We just went into the next line. Calc still means nothing because calc doesn't fully exist yet. So our hello has just been output, right? We're done with that line. So let's go to our output. Hello has been output. So as you can see, the program is running line by line. So let's step into the next line. There we go. Oh my God, calc just became 5. Well, that's not right. Oh, that's what it is. I wrote 2 plus 3. That makes a whole lot of sense, right? So in this way, you can see where that error happened. This is obviously a very simplified example, but if you have a whole bunch of calculations in a row that depend on each other, you can see exactly at what point everything went wrong. So I'm going to click onto the step into function one more time just to show you how the debugger is really working here. Let's click one more time. That means we're past the cout 2 plus 2 is equals line. Let's go to our output and there it is. 2 plus 2 is equal to 5. So this is why I wanted to put my breakpoint just before where the error might be, because this way I could step into each line and see exactly what line caused something to go wrong. To stop the debugger from running, either you can keep clicking the step into until the program ends, or you can prematurely stop it by clicking this button, Stop Debugging. For this last section, I want to go over a couple shortcuts I use regularly because I think they could definitely be useful to you as well. If you recall, to run your program without the debugger, the shortcut is Ctrl F5. With the debugger, it's just F5. Say that you accidentally created an infinite loop. You can break it by doing Ctrl C. If you recall from the previous section, F11 is the step into function to use when debugging a program. Oh my God, I'm clicking forever. Yeah, this must be an infinite loop then. There's also Ctrl F to open the find feature. which is a powerful tool to find anything from variables to functions to even a single character anywhere in your project. As you can see, I have a semicolon here, and it has detected 4 semicolons in my project. What's great about the find feature is its internal replace feature, which you can access by clicking the arrow on the left and typing whatever you want to replace the top value with. You can also toggle different options like match case, which means that your find entry will be case sensitive and only replace those that match its case. Match whole word, which means that if your entry is rock and the system finds rocket, it won't replace it. And use regular expressions, which is a bit more complicated, and I'll provide a link to a Microsoft provided table of its various uses in the description. I'd recommend leaving current documents selected so you don't accidentally replace words in critical solution files in your project. And lastly, there are 2 options on the right that are replace next and replace all. Pretty self-explanatory. I hope you all learned something in this video. I'm sure I missed a few things, so feel free to leave your best tips in the comments below. Maybe I'll do a follow-up to this if there's enough to add. Thanks for watching.